Okay, let's get started. So today we're going to be doing more practice with the SQL, and that'll definitely give you enough to do the first homework assignment, which is due on Monday. In addition to that, I posted this data camp online lesson, which I got some bad news about from students that actually this time around it seems to require you to pay for the service, although maybe some students were somehow cleverly got around it. So I guess you have two options or three options. First, somehow try the hack that the student mentioned. Like, I don't know how it works or if it's going to work. Secondly, pay $20. It's not a lot of money. But third, it's optional, so don't do it. Fourth, this is probably the best optional, is like do this other one instead, which is another online tutorial. So I modified the assignment description to give like option one is the data camp one, and option two is this one, which another student mentioned was a good resource. Yes?
Do you need like a screenshot of like our completion?
No, this is like an alternative, because we don't have a textbook, or we don't have like a required textbook. I'm giving this as like something that you should do to learn the material, but it's not necessary. And if you really are, whoops. Well, should I leave this? What do you think? Off or on? I'm going to try that off. So, if you're really like good at this stuff, or you've done it before a little bit, then you might not have to do it at all. Okay. But it's there as a resource to give you some extra training. All right, any other questions? Yeah, the first homework, how many of you have finished the first homework? How long did it take? An hour? Yeah, it's like pretty easy. It was probably too easy. So I'll get, the second homework will be a lot like harder. And I know that's what you wanted to hear. Yeah, so, come on. Yeah, so last time I gave the basics of SQL. I gave this diagram that showed like the order of keywords that are present in a SQL command, that can be present in a SQL command, but some things could be skipped. And then I gave a 7-step process for building a SQL query that involved these 7 steps up here, which was the reason I gave this is because like the order that the keywords appear in the statement is like a way to say, it's like the way to say what's happening in English. Like select this from this table where this is filtered and blah, blah, blah. Like it's a good syntax, but the process for actually figuring that out actually often works out of order. Like I start with the from, then go to where, then group by, select, having, order, and limit. So it's kind of like jumping around to different positions of the command to figure out, to refine it from a command that gives you like a lot of data to eventually just the data exactly you need to answer the question. Okay. All right. So one thing that came up in the last lecture that was not trivial and that I kind of blew right past, we had a question that asked like, what percentage of ingredients are vegetarian near the end of class? And the answer was like 83%, or I don't know what it was. But at first, we got 0 using the command that was like, but you would expect to give the right answer, because it was taking the total number of vegetarian ingredients divided by the total number of ingredients. It was like 60 divided by 78 or something like that, and it was giving 0. Because it was doing integer division. Okay, so computers store numbers in 2 basic ways. We'll talk a little bit in more detail about some of this later, but I want to give you enough of it now to let you do some interesting queries, and we'll talk about some more nitty-gritty stuff later. But yeah, so computer store numbers is either integers, which are whole numbers, right, including 0 and negative, and floating point. These are also called floats, which are fractional numbers. I mean, technically, it's like a scientific notation represented in binary. But if you want to store a fractional number, you can't do it in an integer. You have to use floating point. Okay. The point being that when you're using SQL, the database management system has to decide to use one format or the other for the number. And by default, if you're doing like count, which is what we were doing to count rows, count is something that is an integer property, right? There's never a fractional number of rows. So when you count the number of rows, it'll give you an integer answer. And if you take two counts of rows, two integers, and divide them, it'll always round it off. But which is a little surprising, but what's even more surprising is the way it rounds it off is to always round down. So like 2 divided by 3 is 0 in integer division instead of being 1, which is what you might expect because it's closer to 1. Yes? It might be called truncation. I don't know. You might see floor used as a mathematical function that converts from a floating point to the one that is down. I don't remember. I think truncation has a specific meaning in floating point, and I don't want to give you the wrong answer. So you can add and subtract integers just fine, but once you try to divide, and you can multiply them just fine, but once you try to divide, the answer is going to have to be an integer, which gives you an approximation, and not just an approximation, one that's always rounded down. Floating point doesn't have that limitation. You can add and multiply and divide and get reasonable answers, but it's not always better than integer for reasons we'll get into later. That's kind of complicated. So the important thing for the purposes of writing these queries that compute fractions and stuff is that you often, especially if you get a 0 where you don't expect a 0, you often have to introduce some kind of silly 1.0 times kind of thing to the formula, because you want to force the computer to use floating point. The way you force a computer to use floating point in a formula is by introducing a floating point number to begin with, which is the 1.0 times. Of course, that won't change the value theoretically, but numerically in the calculation, it'll force it to use floating point instead of integer, and therefore you'll get the answer you want. Okay? Make sense? All right, so just be aware of that. Another new topic for today is aggregation functions. We did a little bit of this last time. We did count to figure out how many rows are being used. In one or two of these homework questions, you have to use sum to calculate the total revenue. Involves adding up a lot of different prices, things like that. So aggregation functions like this allow you to print out not just the values literally that comes from a table, or the values of by multiplying different column, or applying a formula to different values from a row, but actually taking a bunch of rows and doing something to all those different values to get a single aggregation of those different rows. And these particular ones are what you would expect. You can count things up, you can add things up, you can take the minimum or maximum, and you can take the average. Okay. So for example, if we wanted to know how many ounces of ingredients are used, and we had a table that listed out all the different ingredients in a particular recipe here, if we select some amount from recipe ingredients where measurement amount equals 1, the where filters down the result to just those recipe ingredient rows that have measurement amount equals 1. That's because ounce is the measurement amount ID equal to 1. So we just take those rows that correspond to ounces, and we sum up the value of the amount column for all those rows that meet that criterion. Okay, so this gives us a total number of ounces. And we could also, we could have said min amount to see, every time that, among all the times that ounces is used, what's the smallest amount of ounces that's used? Which is kind of a weird question, but you could answer it, or average, or whatever. Right? But those look at all the different rows but that's after filtering with where. So you first throw out the rows that don't match this, and then you aggregate after that. And normally these aggregations apply to all the rows in the intermediate result, but you can use group by to aggregate on subsets of rows where the rows are put into different sets according to some rule. So for example, if you did select sum of amount from recipe ingredients group by measurement amount ID, this is similar to the previous query, but instead of choosing a specific measurement, which was ounce in the last case, we're taking all the ingredients and we're doing a summation separately for the ones that have different measurement amount IDs to list out for every different type of measurement what's the total amount used. We'll see. We'll talk more about grouping later in the next lecture. But the one thing I really want to get across today is aggregations and also subqueries. So we used this a little bit last time, but this is when we had a query that had in parentheses another query, and you just executed the query inside the parentheses first and got the value out and plugged it into the parent query. And these subqueries can return a single value, which is what's used in this comparison. If you're doing an equals comparison, you have to return a single value. It can be a list of values, in which case you could use like an in operator, in, to see whether the measurement amount was in some list of measurement amount possibilities. Or you could actually even do a subquery that returned a table, and then you could replace the table. You could have a subquery here where we're selecting from some like virtual table that was generated by a subquery there. We'll see that in some other examples later on. Okay, but those are always inside parentheses, and they're kind of plugged into the parent expression. Right. Okay, so we're going to do some more examples today using first the sales orders database. So you can follow along if you wish. The first question is list all customers in California and count them. Those are, I guess, two different requests. So you can get started trying to do that. I need to fix my PowerPoint here. Okay, so this is going to be sales orders database. Okay, so there happens to be a customers table, right? So that seems like a pretty obvious place to start. So we can, step one is to use from to choose what tables you're getting data from. And to use that, you have to start off with like a select star template. Select star from customers. And this gives us a listing of the possible data we have to work with to answer this question. List all customers in California. So we want to filter this down to just those that are in California. And there's a column called cust state here. So we can use where to filter. So I add it to the end because I know that's where it goes, but if you look at the diagram that shows like the ordering of commands in a SQL query, where comes after from. And inside the where here, I need to put some kind of a condition that evaluates to either true or false for each row. And where it's true, I'll include the row, and where it's false, I'll exclude the row. And so in this case, we can test the customer state, and we can use like, equality comparison, like so. So this returns just 7 rows instead of previously there were 27 rows. And you can see that these are all in places that are in California, right? So this answers the first part of the question, right? List all the customers in California. If you wanted to list out specific information, not all the information, you could instead of saying star, you could list particular columns. If you put a comma between two column names, you can print out those two columns. Select cust first name, comma, cust last name. You can also kind of join them together, I think with 2 pipes like that. So this is one, it's kind of weird, but I'm printing out one value for every one of these rows. And the value is the result of this formula, which is taking the value of the first name and concatenating it. That's what that double pipe means. That's a string concatenation. So I can concatenating the first name and the last name, which gets this weird thing here. And if I want to make it more readable, I can actually use a literal space in between. All right, so I can do two concatenations. The first name concatenated with an empty, like a space string, and concatenate that with the last name, right? So this is a useful result. I can even rename it with as. This is like a sort of an alias. I can rename this value that's being printed to this column name, full name, and you see that appears here in the title, right? Sound good? Now, how do I take this query and change it into answering the second part of the question, which says count the customers in California instead of, just listing them. Select some star. Yeah. Let's try that. Sum, wrong number of arguments to function sum. So that's saying that we actually need to specify, when we're summing, we need to give the name of a column. Summing actually adds up values. So like we could try to sum, on the right hand side we can see what's available inside customers. And there is, like, okay, you wouldn't want to do this, but just, like for example, if you could sum up the zip code from all the customers. So you're like almost there, but there's one small error. This is not the right answer, by the way. But if we take the zip code for every customer and use sum, that'll add up the zip code. So it takes like 5-digit numbers and adds them up and leads to some huge like 6-digit number. So the point is that sum operates on numbers, whereas what we want to not sum values in the rows, but we want to count the rows. So if we count star instead of sum star, that's what we get. That gives us the answer. So it's close, but different. We could also change this to be like sum and then put in an expression that's equal to 1 every time. Like this sum parentheses 1 also gives the answer 7. Because this is saying it takes this table customers, it filters down to just the rows that have customer state equal to California, and then it prints out for every one of them the value 1 for each one of those rows, and then it sums all those up. So it prints out a 1 for every row and then adds them up. So this is like not the simplest way to answer the question, but it is valid. But like I said, count star would do it. Make sense? Okay. Now, there's a slight variation of this question next, which is to list all the customers in a West Coast state, including California, Oregon, or Washington. All right, so we already have a query that counts them. Okay, let's actually take a step back and we just want to print out the information. So let's say that let's say we want the first name and the last name like we had before, like that. Okay, so this was this is what I had a minute ago, where I was printing out the full name of all the California people. Now we want to modify this so it's California, Oregon, or Washington. So obviously what has to change is this. We have this where clause where it's restricting it to just California, and we need to make it more general, right? So how can we do that? Yes. Yeah. Oregon. and that returns 27 instead of 7. The reason why this works is because for every row in that table, it will evaluate this whole where clause here. And the way that one of these compound predicates with or between it works is that it tests the first thing, customer state equals California. If that's true, then it says, okay, fine, that the answer is true. But if it's false, it checks the next one. And if that's true, it returns true. If it's not, it goes on to the next one. So it can test all three of these, and only if none of these are true will it return false for the whole row. Yes?
That one time you did not end, so could you do end for that?
Yeah, good memory. So the next step to improving this is to use an in keyword, if that's the right word, where you can actually test to see whether, in a much shorter fashion, you could test to see whether the value of that column is in some set of 3. Right? So we're testing whether customer state is in the set CA, WA, or OR. Okay, and this allows us to, like, if this was a list of like 5 or 10 different states, it would still be pretty short, even though we had a long list, whereas the one with the ORs was pretty long because it was listing cut state equals every time. Okay, so they're both correct, but this is a shorter way to write it. Okay, makes sense? All right. So this is a more difficult question. Count the unique customer area codes in California. So we can start off, let's start from scratch and go through this process, right? We're still going to use the customers table, actually. Because if you look at, just as a guess, if we guessed customers table and then looked at it, we would see that we have both the state information and the phone number and the customer area code for the phone number listed in this one table. So we have all the information we need in this table. We just need to filter it down and process it correctly. So in this case, what filter do we need to apply to start answering this question? Anyone? Yeah, customer state equals to CA. Now remember, we're not going to get there, in exactly one step. We're just trying to get closer to the answer. When I add that, now I have, instead of 27 customers, I have, or I don't know what it was before, but I have just 7 customers. I still don't have the answer of the unique customer area codes, but I have a reduced set of data that's more relevant to answering this question. Yes. You use 2 hyphens, like this. Okay, so it was 27 rows originally, and I've commented out the second row. I can delete that and run it again to get the 7 rows. Yeah. All right, so we've filtered it down as much as we can, because we do need all 7 of these to answer the question. We're not going to do any grouping. We're not really going to do any grouping today, so we'll just skip that. Select, step number 4 is where you choose what to return, which could be listing out column names or doing some formula over columns. And in this case, what are we going to select instead of just selecting all the values? Yeah.
Select the distinct count.
Yeah, I haven't actually... I guess I haven't given this... I haven't explained this or just even described this as an option. But the count aggregator has an option where you can count not just the number of times number of rows there are, but you can also count the number of distinct values there are for a column. So in this case, running it like this will, I think, tell us that there are 6 distinct area codes in this table after you filter out to include just those that have the customer state of California. So previously we did count star to just count all the rows, but now we're counting just those rows that meet have distinct values for a certain column. Okay. And I think that's the right answer. Let's try to undo it and just test it by browsing. So of these 7, we have the first one repeats, and the other ones look like they're all different. So I think that's the right answer. Okay. This next question is asking, what's the full address of customer John Viescas? So we can start by browsing the data to figure out where what we might have for that customer. Select star from customers. I think it's plural. So one of these is John Viescas here. But to start with, I have the whole table. So I can filter down to just the one that's that one person. So I'm going to say cust first name equals John. And that will give me 2 answers. So I can do each one of these steps iteratively too. So that's not good enough. I need to be more specific. I can add an and to that filter, and require that also the customer last name is Viescas. And that'll return just one row, most likely. I mean, depending on what's in the database, of course, the number of rows returned could be different. You could have 2 customers with the same name, or you could have none with that name. Yep.
Is there like a little hack, like similar to the AND or in function that we just learned, but like for AND?
Well, this is, as far as I know, this is as short as it can be, because nothing is actually repeated here. We have 2 different column names. So if we wanted to test whether a whole set, yeah, I mean, theoretically, you might, yeah, there isn't anything to let you like quickly list out, like in parentheses, like 3 different columns, parentheses equals, and then like 3 other columns. There isn't anything like that, unfortunately. Yeah. Mm-hmm.
Does in only work with or statements?
Yeah, in does something like an or comparison. It checks to see whether a value is in a set that you list out, which is equivalent to testing whether it's equal to any one of the elements, which is an or, basically. Okay, so here we have the row that we need, but we haven't answered the question, what's the full address of this customer? So basically, it's asking us to print out a piece of this data, of this row, which is, the street address, the city, and the state, and the zip code, like you'd see on a shipping label or something. So we need to change what's being printed from star to something more specific. And you saw me do this before with the pipes, where you can sort of add things together. Let's see if this works. We have the street address and also the city, and then some stuff in between. I'm trying to put a new line character. I'm not sure that'll work. Actually, I don't need that. I need city, comma, space, zip code, right? I didn't like the new line character, so maybe I'll just put a space or period space. Okay, so the answer, and then let me rename this so it's a little more clear. Make this bigger. Okay, so then now what's printed out is the street address, period space, the city, comma space, the zip code. I guess I need the state as well. But you see how this whole thing on the second and third line is like one big formula that is being applied to, these, I'm not sure why it printed, there shouldn't be quotes around this customer city. I don't even know why that worked. It should have just printed the string cuss city, right? Maybe I didn't run it. Was there an error message before? I don't know. Let's test that out. If I put quotes around that and run it. What? Okay, it's just being way too clever for its own good. Maybe if I put single quotes, it would probably, yeah, if I put single quotes, it treats it as a string literal. And then you see it down there. Yeah. But obviously that's not what I want. I want the name of the city. Okay. All right. Next question is a little more interesting. This is in the same database, but using a different table. What's the single most expensive product? And then follow-up questions. What's the cheapest 5? And by the way, the answers to all these questions are in the slides. So you can cheat now, but more importantly, you don't have to write down my answer if you want to see it later. You can see it in the slides. Most expensive product. So where do we start with that? Usually I always start with select star from something. In this case, what's it going to be? What am I selecting from? Yep. Products, yeah, probably. Let's have a try. When I do that, it lists this stuff. You see there's a column that says retail price, so that'll tell us like what's most expensive. We can use that. So how do we find the most expensive product? Yes. Yes, but I was hoping you were going to give me the wrong answer, which is to look for the maximum of retail price, right? We'll come back to what you said, which is the right answer. But you can get, if you look at the maximum retail price, like $1,800 is the most expensive product, right? So you can get that number like this, like in very quickly. But the problem with this is it's not telling you what the product is, it's just telling you the price. Right? So there's no like argmax function that will tell you like what is the value of a column where some other column is maximized, something like that. So instead you have to do what you just said, which is figure out a way to find that maximum value, the name of that maximum value column, maximum value row, without actually using maximum. So 2 ways to do this, right? So one is you can take this value, this price value, and use it to pick out the data you want to get, right? Like if I put it around in parentheses, this is essentially equivalent to me typing in 1800 if I have that query within parentheses. So I can like select star from products where retail price is equal to that. See that? So I have 2 queries, one within another. The subquery on the right-hand side finds what the value of that most expensive product is. And then like we go back a second time and say, okay, now that I know that $1,800 is the price of that really expensive thing, I want to find the name of that. So it's finding all the information about the products. And in particular, I could narrow it down to just print out the product name. Give me, this is going over. Let me do a carriage return. Give me the product name from the products table where the retail price of that product is equal to 1,800. And 1,800 comes from the subquery that finds the maximum retail price out of all the products. Okay, so does that make sense as a solution to this problem? Yeah, but there's a better way to do it, which you said, using sorting and limiting. And tell me again what that was. Yeah. Order by retail price, limit 1. Or you got to do it descending. It gives the same answer. This is in less code. It doesn't use a subquery. So basically, it's getting the work is happening in this last clause, sort of the step 6 and 7 of this process I described. If I remove this for a second, just comment it out, and then run it, I get a list of all the product names. If just to clarify, I can also print out the retail price. So if I can put two things here to be printed out. So here are all the products and their and their prices, right? And if I add these additional things in piece by piece, if I order by retail price, that prints the same data, but it orders it according to the retail price, right? So the most expensive thing is at the bottom. If I add descending, it reverses the order of the sort. So the most expensive thing is on top, right? It still lists all this stuff for all 40 products. Then I add limit 1 to limit my results to just one thing, and that one thing will be the most expensive thing because I ordered it by price and put the most expensive thing on top, right? Yeah. That's how we do it. So how do we change this to get the cheapest product? Yeah, question?
Question about this one.
Mm-hmm.
Using the subquery to find the max price would be better in situations where products both have the same price.
Yeah, that's true. Yeah, if you had two products that were both $1,800 and you wanted to see them both and you didn't want to just have like a sample of like one of them, then that would give you a different answer and perhaps a better answer. The question was, what is the single most expensive product? I mean, you have to interpret this language to figure out what it's even asking for, because single kind of implies that you want to see one. But I understand why you'd want to see more than one if they're the same price. Yeah. But somehow but then this query is like simpler to write, so then that's an advantage as well. And it probably would run more efficiently because it does one query instead of two. We can change this to get the cheapest price, the cheapest product, by just changing the way the sorting is happening, right? So instead of sorting descending, we can sort ascending, like this, right? So it's just ordering from small to large instead of large to small. We're still limiting by 1 to get the cheapest, and then to get the cheapest 5, we would change the limit to get 5 instead of 1. Right? Make sense? All right. Yeah, what's the value of product inventory on hand? This is a more complicated question still. Value of the product inventory on hand. So this is one where we probably need to do a little bit of exploration to figure out what does inventory mean in this context and how is it stored. Okay, so the tables we have are categories, probably not it, customers, employees, order details, orders, product vendors, products. Let's try products. Okay, so products table actually has a column called quantity on hand. So quantity on hand means inventory on hand. So that's what we're basically counting that up for all the products. But we're not just counting up the inventory, but we're counting the value of the inventory that's on hand. So that column doesn't directly give us the answer, even if we aggregate it, because it just tells us how many of these things are available. We have to apply the price information to get the value of all that stuff, right? So we can start off by getting everything from that table. Select star from products. And we have the price, quantity on hand, the name, that kind of stuff. So how do we change this to get the value of all these of this inventory? Yep. Yeah. So if we take the retail price, we for every row it'll take the value of the retail price. It'll compute this formula, right? So it'll take the retail price on that row and multiply it by the quantity on hand for that row. That gives you a value for each row, which is like the value of that kind of product that's in the inventory, and then we can sum it all up to get the total for across all the products, right? And that gives an answer like 85,000 seems about right for a bicycle store. Yeah. The second variation of the question is asking more specifically, what's the value of the bicycle inventory, which is a specific type of product. So now it's asking the same question, but I want you to look at not all the products, but just a subset of the products. So how do we start to answer that question? Yes.
Use a where to like select the bikes.
Yes. So the where goes after the from, and we want to use that where to narrow down the results to the scope of just bikes and not all the products, right? In order to do that, we can only test based on the columns that are available here, and you could use the product name, maybe the product description, category ID. Those are all options. So what is category ID? There's a categories table that has like numbers for different categories. And if you look at this, you'll see that category ID number 2 is bikes. So that tells us that we can filter using that, right? So we can say where category ID equals 2. And running that query, the answer goes from 80-something thousand down to 33,000. And that seems about right. Right. We might also be able to answer it in a different way. We could say where product name like bike. That's not quite right, but so what I'm doing in this case is summing up the value of inventories for all the products that have the word bike in the name somewhere. So like is a comparison, a string comparison. So it takes the text in this product name category and tests to see whether it matches a pattern. And the pattern is like a regular text, except it also can have a % sign to match arbitrary text. So in this case, I'm allowing arbitrary text on the left and the right-hand side of the word bike, so it's testing to see whether the word bike appears anywhere in the name. And there are some products like that, and the value of all those inventory-wise is 34,000. But then there also are products like bike helmet and like bike light and whatever. So this doesn't actually precisely answer the question because it's not really bike inventory. It's just products with the word bike in it, if that makes sense. Okay. All right, so those were the answers for those in a few different ways. And let's take a 1 minute break. I'm going to get some water, and we'll continue in a minute. Okay, so we're going to do some more examples using a different database. This time it's a school scheduling database. So again, you can follow along if you've downloaded the databases from Canvas. This is a more complicated database, has more tables. Okay. The first question being asked here is asking what is the mean average classroom capacity at this university. And you see we have a ton of tables to choose from. But among these tables, obviously, the classroom table stands out as being a good candidate for getting this information. So let's start there, right? Select star from class underscore rooms. What do we get? Names of the rooms, buildings, some information about whether there's a telephone there, and the capacity. So, how can we use that? Do we need to filter? No, because we're asking about all the classrooms, right? We want to get an average of all the classroom capacities. We don't need to do any grouping because we want one aggregate, not many different groups of calculations, different averages. But we know we want this capacity number. We can select capacity from classrooms, and that just gives us a list of capacities. And then it's a simple task to just add an aggregator to it. AVG is the average, the mean average. And that gives us this answer of 47.08, whatever, right? Easy enough, right? You could also technically sum up the capacities and divide by the number of rooms, right? That would be select count star from classrooms. And you'd have to make these both subqueries by putting them in parentheses. And you have to put a select in front of it. And it gives you 47, which is not the same exact answer, but it's a rounded version of that answer. Yeah.
So I know we don't necessarily care in this
Mm-hmm.
situation, but how do we make these floating point values?
Yeah. So what you can do is, it's a good question. And that's what I was going to do next. If you add to the beginning of this calculation a floating point literal, if you type out 1.0, then SQL knows you mean a floating point, so it'll store that as floating point, and then it'll do this calculation starting with a floating point, and then multiplying by an integer result. Integer times float is going to be float, and then float divided by integer is going to be a float again. As long as there's at least one float involved, it'll force it to be float because it doesn't want to. If it knows enough, if it has a hint that you might want to use floating point, then it'll use floating point. So this gave the same answer in a much more complicated way. Okay, but only after I added the 1.0 times. All right, but let's go back to the way I had it before. Well, no, actually, let's leave that. The second variation is more complicated. What is the median classroom capacity at this university? So median, of course, is like if you were to sort. Well, I'm giving you the answer. the middle value in the sense that half of the classrooms are bigger and half the classrooms are smaller. That's what the median is, right? That could be quite different than the average because an average is very sensitive to outliers. So if you had one classroom that had a capacity of like 1 million, that could make your mean average very high, but it wouldn't affect your median. So in this case, how do we calculate the median? How do we start to calculate the median? Yeah. Yeah, you want to sort them, right? Because the way I defined median to begin with, was that when you sort the numbers, it's in the middle, right? So let's print out the capacities. and order them. Order by capacity. You notice I have to say capacity twice because it doesn't like know what's. You need to tell it explicitly what to sort by. So here is a list of 47 rooms sorted from 15 to 120 capacity. So, as a human person, I can look at this and say, okay, 47 is the number of rows, and 47 divided by 2 is like 23 and a half. So I should look at 23 and a half position and get the answer is 40. Right? That's kind of like that's a way I could kind of solve the question. But that's not a SQL query that gives me the answer directly. That's like I have a SQL query that gives an intermediate result that I then like manually sort of on pencil and paper in my head use to get the final answer. If I want to get this all in SQL, I need to do a little more work, but I can do the same kind of work I did in my head, right? So remember, what did I do? I got the total count, 47, divided it by 2, and I used that to index into the list. So somehow I figured out that I wanted the 23rd or 24th entry and printed that. Right? So let's take this sorted list and keep it there on the side. But then at the same time, let's build out a query to get the number 27 and a half. Right? Which is the number of rows divided by 2, right? If I divide by 2.0, I get 23.5. Except I'm going to end up using this as an index into a list, so I actually want an integer, not a floating point. So it's actually beneficial to have it round. So I'm just going to say divide by 2. Okay, so you see how this second query gives me the number of rooms divided by 2. Okay, so now I have 23. And I want somehow to combine these, right? I want the 23rd entry from the first query. Okay. Any ideas for that? So on this in this sort of toolbox that we have here, we can order and we can limit. We don't have anything that like picks out the nth entry directly. That's the trick here. We don't actually have anything to get the answer in one step, really. But we can get the top n, which is kind of similar in principle, and we can combine two of those to get the nth element. Right? Like if we were to get the top 23, and then reverse the order and take the top 1, that would do it, right? So if we take the same query we had before and add a limit, and then use a subquery to define what the parameter is of that limit. All right, so now we're printing out the classrooms in sorted order, but we're stopping when we get to the median, basically, right? Because the limit, the number of results is limited to half of the total number of classrooms. Make sense? And now the answer we want is the last thing in this list, except we can't really programmatically print that out because that the limit doesn't give us that. Yeah, you have an idea? We can print the max. Okay, so where would we put that? Like max capacity? Let's see if that works. I'm not sure it'll work. It gives 120 because it prints out. This limit actually applies after this aggregation. Yeah, so it doesn't do it. So finally, we're getting to a question that's somewhat difficult. But if we come back to this, okay, again, we have the list of classrooms sorted. We want the last one in here. So let's use this. Now, this is something new. Let's use this as a subquery that returns a table instead of a value that's used in a comparison. So previously, the subqueries we did were always for like this equals that, and the right-hand side of that equation was a subquery. Now we're going to use this as a table, because basically what we want to do is we want to print out the maximum of this table, right? We couldn't do it directly with max, but we can treat this whole thing as a temporary table and then do a query on that temporary table, right? So we can, if we put in parentheses, that creates the subquery that returns a 2D result, which is a table. We can select max. Let's do it in caps. Capacity, because that from this subquery that returns a table of capacities. Except the subquery, of course, limits what's returned to just those that are in the first half. So this query returns the median classroom capacity in a very kind of roundabout way. In some databases, there is a function. Like I think if you were to use like Oracle or Microsoft SQL Server, you could get median just in like one line. But it's not a standard SQL aggregator. It's not available in SQLite. It's not available. Well, I don't know if it's available in MySQL. But this is a way. There will often be cases when you. This is a great example of using the limited tools you have in SQL to answer a question which seems pretty fundamental or easy, but it's just a little bit beyond what's available natively, and you have to be creative and somehow put together the tools you have to answer the question. Yeah, here. Welcome to you. Yeah, so technically the definition of median is if you have an even number, you take the two middle values and you average them. So I don't want to try to answer that. To answer that precisely, I believe you need what's like a case statement, which is kind of like an if then else, which is possible in SQL, but it would bleed to code that was probably like about like 15 lines long, and it would have a case statement which we haven't covered yet. I would stick. Yeah, I wouldn't. Yeah, so this is enough for now. Yeah. 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 Yeah, so are you saying, let's take a simpler example. So I think I see what you're saying. If we have 3 entries, we want the second one. 3 divided by 2 is 1, right? Which is not what we want. We want the second one. So I think we want actually to add 1 to it. Right, so I think what you're saying is that we should have, the limit should be 1 plus this here. Something like that. Yeah, I think that's actually right. Yeah, good point. Mm-hmm. Asking about this?
I'm talking about an output.
Yeah.
Like those ones, and like when it lists out the rows and stuff, like you can't really like say the first or second or anything.
Yeah, I mean the only what you have available to you is SQL commands, and you write those up here, and the output is down here, and the output's in general 2D matrix of like a table that has columns and rows. I mean, like you have access to it in a sense that's on the screen and you can read it. And if you were running this inside of, let's say, a Python or R program, you could do a query and get a result that was a table and then run some like Python code to pick out the nth element or the last element. So there are ways to take, yeah. But what I'm showing so far is like what you can do with just pure SQL in one shot, kind of. If that makes sense? So yeah, I didn't have that originally, but the student just mentioned that the division I was doing of taking the total number divided by 2 actually gives me not the middle one, but the one that's to the left of the middle one. The example was if we have 3 elements, and we want the median one is here, right? 3 divided by 2 is 1.5, but if we round that down, it becomes 1. And 1, of course, is here, right? So this is what I had originally, which was wrong, so I added 1 to it, because if you just work it out, 5 divided by 2 is 2.5, which gives you 2, but actually I want 3. It's always going to be plus 1. Yeah, because of the round down, and it's also because of the fact that we're using one-based indexing. Like if you're using a different programming language, then a lot of times the first element is element 0, like in Python, and one of the reasons for that is because if you divide by 0, you get the middle. One of the consequences is the middle element is doesn't have to have this plus 1 on it. Yeah, that makes sense. Okay, so that was the median. Great. Here's another question that's somewhat difficult. How much classroom capacity is there in each building? And the hint here is to use group by, which we haven't really talked about formally, and I'll have a couple of slides on it next lecture. And I believe that it's not really until the second homework that you have to use group by. But let's start trying to use it. How much classroom capacity is there in each building? You'll see that the buildings table doesn't have anything about classroom capacity, so it's not directly available. We have to infer the classroom capacity based on looking at all the classrooms. Each classroom lists a capacity for itself, and then but it also has a building code. So you can do an aggregation of adding up all the capacities, but then dividing it according to sets, where each set has a unique building code. Okay. So let me show you what that looks like. Let's start with the classrooms. Have to say from, select star, from classrooms. So we have all the capacities listed on the right side, and we have the building codes here in the second column. And basically what we want to do is for all the ones that have the same building code, we want to add those up. And that'll tell us what the classroom capacity is in each building. Okay. So basically the trick here is that if we want to do something like a sum of the capacity, right? But this gives us the sum of the capacity of all the classrooms in the whole university. It doesn't divide it according to the buildings, right? So we have to, we actually need to use this step 3, this group by, to make this aggregator apply not to the whole list of rows, but to different sets of rows. And we have to specify some kind of predicate, which is to say, a formula that evaluates, not a predicate, but just a formula that evaluates to different values for different rows, and for rows that we want to combine, it should evaluate to the same value. And in this case, the formula is a way of is not maybe just it's too complicated because it's just one thing that we can group by. We want the building code to be the same for all the ones we're adding up, right? So if we group by building code, that performs a series of sums, not just one sum. And for each one of these sums, what we know is that all the rows that were added together had something in common. Specifically, they had this in common, whatever's after the group by. They had the same building code. Okay. And to make this more clear, I'm going to print out the building code as well as the sum. Building code comma sum capacity. So now you see that this AS building, the sum of the capacity for that building is 370 because all the classrooms that had that building code were summed together to get this number. Sound good? Yes. Yes, there is, using a join, which we haven't got to. But the reason why we have this kind of limited and inconvenient code is because the table we're working with, classrooms, is using building code, right? So it's very easy to use what's already here. So we aggregate based on what's here and we print what's here. If we wanted to be more fancy, we take the same result and we basically want to cross-reference these codes with another table to get the name. To do that, you use a join. So I'm not going to cover this until next lecture, but just to give you a little, because you asked, we could join with a table that has more information, which is buildings. And I print out the building name. Let's say the code and the name. Okay. So now we're actually getting data from not just one table, but two tables. And they're joined together, kind of like if you remember back to that first couple lectures, I had like staff information where there were like multiple tables that were cross-referenced to each other. The same thing is true here. Classrooms have these codes, but if you cross-reference that code with the building table, you can get a name. And now you see the AS actually is Arts and Sciences, and Arts and Sciences has capacity 370. Okay. All right. Okay, another question. How many classes does each instructor teach on average? So where do we get this information? Which one table has information about classes being taught by instructors, the number of classes? Yeah? Faculty classes? Perhaps? Let's see what's there. In this table, this table creates a relationship between classes and staff. So basically, it's saying for each one of these rows, it's creating an assignment between classes and staff. So this class 1000 is being taught by staff number 98014, and the same class actually I think can have multiple staff, maybe not. But anyway, for sure, the same staff member can appear multiple times here with different class IDs if they happen to be teaching different classes, right? So, okay, that's the start. Now, we want to compute how many each instructor teaches on average. Is there any filtering we need to do here to throw out any of these rows, or do we need all of them? Every one of these rows is a record of a staff member teaching a class. So we need all of those in our answer. So we're not going to do any filtering. Do we need to do any grouping? Grouping allows us to do an aggregation of not every row, but different sets of rows. So let me actually take a step back and ask you, if you had this table, right, 130 rows, it tells us, has staff ID and class ID, and you wanted to answer this question, how would you do it? How would you do it on pencil and paper to calculate how many classes each instructor teaches on average? Yeah. Count how many times each staff ID corresponds with a class. But how can you actually do that? More mechanically, in greater detail. Count the number of staff IDs that are the same. What do you mean by it, that are the same? Count how many times it shows up. Okay, so the fact that these two, this is probably what you meant. These two numbers appear twice means that this person teaches at least two, and if it appears again, they teach again. So you have to count the number of times that each number appears, basically, right? So you could scan from the top, And you would, every time you see a staff ID, you check to see whether it's already on your list. If it's not, you would add it there. But if it's already in your list, you would kind of like increment the number from 1 to 2, from 2 to 3, and so on, right? So, yeah, so you want to count the number of times staff ID appears. Each unique staff ID appears. So how do you do that in SQL? Using a group by and an aggregator. So I think I use the word count, right? You want to count the number of appearances of staff ID. So let's just start by assuming we're going to count. We're going to use a count aggregator, right? If we count star from faculty classes, we get the answer of 130, which says there are 130 rows in faculty classes. So 130 teachings are happening, right? The thing is, we just need to decide. It's not one person teaching 130 times. It's, n number of people teaching 130 times. There are two ways to answer this question, I guess, now that I think about it. So, one way to answer it was what we were saying before, going through and calculating the number of classes taught by each instructor across all the instructors, right? And then averaging that. Another is to take the total number of classes and divide it by the number of instructors, right? The total number of classes taught divided by the number of instructors has to be equal to the average of number of classes taught by instructors. So if there's one instructor, the answer is 130. If there are two instructors, then we know that they each, on average, teach half of them, right?
So you're looking for like the overall average.
Yeah. Yeah, the way I stated it at first, it seemed like there was the answer had to be computed in a complicated way. But actually, if you think about it differently, there's a pretty simple solution, which is to count the classes divided by the number of instructors. All right. So we have the number of classes here, and we need to divide it by the number of instructors, which is what? Yeah, this is similar to what we did in an earlier example. Count distinct staff ID, I think, from faculty classes. Same table. And the answer is 5. There's probably some round off, so let's add a 1.0 to the beginning to make it floating point. And the answer is 5.9. Okay. Seems about right, maybe. Now, what I was getting at before is a different way to, let me make another tab. A different way to answer this, different way to answer this question is using aggregation. So if we start off just counting all of the classes being taught, 130. We could think about splitting those up among the different faculty using a grouping. So if we group by staff ID, and we can print the staff ID too. So this table here shows us now for each staff member how many classes do they teach. Right, and the way that works is it's still adding up or counting rather the number of classes, but it's doing that on a set of discrete subsets of a set of disjoint subsets of this rows of the table according to this group by thing. Right, so every time the staff ID has a different value, those rows are put in a different bucket. So the first bucket here is all the rows that have staff ID of 98005, and then this aggregator count is applied to all of those rows, which just counts up the number of them, which is 4. Okay, so this table gives us the number of all the classes taught by different faculty. And if we want to compute an average of something that's already aggregated, we have to actually do a subquery, sort of like how we did before. So I can compute the average of this count thing, but I have to give it a name like C. Otherwise, I can't refer to it. Average of C from this. Is that the same as what we got before? It is. Okay, so before we calculated this by just counting the number of teachings and dividing it by the number of distinct staff members in the association between classes and faculty. And then in this other example, I actually came up with a list of like every faculty member's classes they were teaching. And then on that table, I computed an average of all the values. Okay. There's one more example I had, but we'll skip that. So that's class today. Next time we'll do joins and groupings in more detail. And joins are pretty exciting because they let you answer much more difficult questions, and they're actually a lot harder to understand than these simple queries.